Okay, in this podcast we're going to learn how to write chemical equations in a way that you are required to do so for the AP exam. So you can write a molecular equation, a full ionic equation, or a net ionic equation, but the net ionic equation is the one that you have to write on the AP exam. But usually you start with a molecular equation, so let's just look at a molecular equation first. And I know this is not in your notes, but writing this will help you remember. So a molecular equation shows the reactants and products in their molecular or compound form. So, for instance, if I have sodium chloride, I would show it as sodium chloride as opposed to the sodium ion and the chlorine ion. Okay? So here is an example of a molecular equation. It shows silver nitrate, even though it's aqueous, and I'm going to have these ions floating around, it shows the full compound. Now what you need to do on the AP exam is write net ionic equations, okay, which only show the species involved in the reaction. Okay, there are lots of ions floating around when you have a ionic compounds, aqueous solution of ionic compounds reacting. Some of those are just spectators, but the rest, the ones that are actually involved in creating new substances, are those that show up in the net ionic equation. So, in the aqueous reaction, a lot of stuff is floating around as spectators. They're just watching, but they're not participating in creating a new substance. So, if the same ions are there before and after the reaction, they are just spectators. So, when you want to write a net ionic equation, you start off with a molecular equation, and then you decide what to write as ions, what to separate and write as ions. And what you want to do is write all strong electrolytes as ions. So let's review what are strong electrolytes. They are soluble ionic compounds. Okay, anything that will dissolve, that's an ionic compound. They are strong acids and strong bases. And once you have done that, you can take a look at the ions on either side of the equation, and any that are the same on both sides, drop any ions that are the same, because they're just going to be the spectators. So let's do some practice. So let's take a look at that equation you have on the top of your page 17. So here I have silver nitrate. So you have to be able to take the words and write the formulas, right? So make sure you know how to do that. Silver is always a +1, nitrate's a -1. So that's a balanced formula. Plus KCl gives me swap partners, right? And I look at my solubility rules and see that silver chloride is a solid. It's going to be insoluble. Okay. So the total ionic equation, here is where I decide which substances, if they are soluble, I'm going to separate them as ions. And I'm going to write it above this line. So I'm going to have Ag plus, which is aqueous, plus nitrate. Anything with nitrate is going to be aqueous, right? And when you're writing ions, you must show the charges. Otherwise, they are not ions. They are atoms, right? So if you can do all this and you don't get the ion charges, then you don't get any credit. Now, silver chloride is not soluble. It's insoluble, so I leave that as a compound and write it as the molecular formula, plus NO3 minus, and both of these are aqueous. Okay, now to get the net ionic, I'm going to eliminate any spectators. So I have a nitrate here, and a nitrate here, and a potassium here, and a potassium here. So my net ionic, which I'll write above the line, is going to be my silver, which is aqueous, plus my chloride, which is also aqueous, and it's going to give me silver chloride solid. So that is my net ionic equation. So the product is the new compound that's formed, and the reactants are what's required to make that. Let's take a look at another one. You go ahead and try it. Alright, so I have calcium chloride. Calcium's a +2. Chloride's a -1, so CaCl2, plus sodium carbonate. Carbonate is CO3, and it's got a -2 charge, so I need 2 of those. Okay, when I do my double replacement, calcium and sodium switch places, and I end up with NaCl plus calcium, which is a +2. Carbonate's a -2, so that works, and I need 2 of these here. Okay, so if I look at the solubility rules, this is certainly soluble, and this is not. This is going to be a solid. Okay, so when I write my net ionic equation, I can either write all my ions, which I'll do this time, and next time I'll do the shortcut. So I have a calcium +2 plus Cl minus, and these are both aqueous, and I have 2 Cl minuses, right? Don't make a mistake of putting the 2 as a subscript, because it's an ion now. It's not a molecule. I have 2 Na pluses, that's aqueous, plus the carbonate, and I'll write it as 2 minus instead of -2. I'm going to get 2 Na plus 2 Cl minus, both are aqueous, plus CaCO3 solid. Okay, so let's eliminate spectators. 2 chlorine, 2 chlorine, 2 sodium, 2 sodium. My net ionic then is Ca, I'll write it as 2 plus CO3, 2 minus. They are both aqueous. And I get calcium carbonate solid. So sodium and chlorine were just spectators. I focus on the things involved in creating the new product. Alright, aqueous solutions of ammonium phosphate and sodium sulfate are mixed. Okay, ammonium, that's ammonium, it's got a +1. A phosphate, PO4, has a -3, so I'm going to need 3 of these. Plus sodium sulfate, sulfate's a -2, so we need 2 of those. Alright, if I do my, this should have a 3 around it. If I do my swapping, my positive ions switch places, so I end up with sodium phosphate plus ammonium sulfate. Okay? And those formulas are balanced. Now I got to look at these and decide if either of these are a new product. Anything with sodium in it is always soluble. Anything with ammonium in it is always soluble. So if I were to write the net ionic for this, MH4 plus, so I have 3 of those, plus PO4, 3 minus. I'm not going to write the aqueous because I'm being a little bit lazy. I'm actually out of room. And I get 3 Na plus PO4, 3 minus, plus NH4 plus 2 of those, plus SO4, 2 minus. If I look at what my spectators are, no, I didn't balance this whole thing. And let me see, I would need this to be a 2, and I would need this to be a 2, and this to be a 3, and this to be a 3. Okay, so I need to change the coefficients here, but you're going to get the idea. If I just look at this now, and I look at eliminating spectators, this is what I end up with. Ammonium is a spectator, phosphate's a spectator, sodium's a spectator, sulfate's a spectator. They are all spectators. I have not formed any new products, so this is an NR, abbreviation for no reaction. Okay, I did not form a new product. Alright. Aqueous solutions of aluminum chloride and sodium hydroxide. AlCl3 plus sodium hydroxide. They swap partners, and I end up with AlOH3 plus NaCl. If you're not good at balancing equations or writing formulas for equations, more importantly, then I recommend that you would do some practice this summer, because it's expected that you're coming in knowing how to do that. Alright, so I think that should do it. Alright, so I got to look at my products and decide. So these are aqueous, right? I've got to decide sodium chloride is soluble, but aluminum hydroxide is going to be a solid. Okay, so here I'm going to do the shortcut. So I'm going to only put my new substance, which is the aluminum hydroxide solid there. And on this side, I'm going to indicate what ions were necessary to form it. Okay, you could write the whole full ionic equation and then just write the net ionic, but I just skipped ahead, and either way, you're going to be good. Alright, this is the last one. I have lithium sulfate, sulfate's a 2 charge, and calcium nitrate. Whoops, that should be NO3, and I need 2 of the nitrates because calcium's a +2. And I'm going to get calcium sulfate plus 2 lithium nitrates. Alright, calcium sulfate is what's insoluble, so I formed a solid. So I'm going to put that down as my solid, and then I'm going to indicate which ions formed this. And that's going to be my net ionic. I need aqueous symbols. Alright, we're going to stop right there.